Okay, good morning. So, in the last class, we talked about the regular guide wires. So, today we're going to spend some time understanding the wires that we use inside the brain. Okay, now it's very important that we understand that very clearly because the construction of these wires are very important. That lets us know exactly where to use what wire. Remember also, in the vast majority of neuro procedures, we'll be using a wire which is a 1,4 wire. So let's have a look why we say 1,4. For example, if you look at this, it's got synchro and it's 1,4 written out here. You can just see. So this 1,4 basically means it is 0.14 of an inch. Get this point? So remember, the vast majority of your microcatheters that you use for coiling will be using a 1,4 wire, and the other wire that we have is a Traxxas wire, which we'll be talking in great detail. Again, you look at it, this is also another wire. If you see 0.14 inch, right? So remember, the 0.14 wires are the most important wires. Here is another wire, again Traxxas, again 0.14. So the first part of this class is going to be about the 0.14 wire. And the first wire I'm going to explain to you is a wire called the Traxxas wire. Okay. Now, Traxxas basically comes in two basic, what do you call it, as two basic, what you may call a rigidity. One is called the EX, which is an extra support wire, and which is an ordinary wire. Now, why is Traxxas one of the most complex wires that has been made and also an exceptionally good wire? It is primarily because the company that made the first Nitinol wire, Terumo, was the company that purchased a company called Microvention of. Once they purchased Microvention, they transferred their technology of Nitinol and coating onto Microvention. Now, last time when I told you about Nitinol. I told you it is basically N stands for nickel and the T for titanium. And I think by mistake I told you NASA. It's not NASA actually. The NOL stands from the Naval Ordnance Laboratory. NOL is Naval Ordnance Laboratory because they were the people who first made this material. I told you Nitinol is an exceptional material because it's called a shape memory alloy. So what does it mean by shape memory alloy? It basically means that it has got a shape that can be given at a temperature, and after that, at that temperature, it will always come back to the shape. Also, I told you one of the greatest advantage of Nitinol that it has got very high elasticity. That means you can bend and it will come out. So let me show you a little bit about the wire. This wire comes basically at a length of 200 centimeters. Now this is a wire where I have given a shape. The original wire does not have a shape. It will be straight. Now, if you look at this wire carefully, it's very difficult to see it, but you can see that, let me use this as a marker for you to make you understand. See the distal part of the wire, the distal part of this wire is got a coil. This coil is a combination of platinum and nickel, the same nickel that is used for making Nitinol. Now, why have they given this 4 centimeters as platinum with nickel? Now, platinum is very, very radio opaque. So, if you want to see it fluoroscopically, you need platinum. It has got a very high atomic number. The same reason why they use platinum for making for making intracranial coils, which you use for aneurysms. Now, so the outer coil is made out of platinum and nickel. After 4 centimeters, you will have close to 36 centimeters of coiling, which is done with stainless steel. You can see that this is all looking like steel, and then at a point it will become black. I hope you can see this black component. Now see, this transition is when it is now going to move into just outer coating, which is basically a very, very hydrophilic substance. I hope you're getting this whole thing. So the outer coating is made of three components. The distal 4 centimeters is basically platinum along with nickel. 36 centimeters is steel coiling. After that, it goes into a coiling which is basically a polyethylene bonded material, which makes it reasonably slippery. Also, we have to now understand what lies inside this. We talked about it yesterday and said every wire has two components. What are the two components in every wire? One component is the coil outside. The second component is the mandrel. So this has got a very, very interesting mandrel. The central mandrel is made out of nitinol for 60 centimeters. You understand that? So all over here, as it comes down, it is going to be nitinol. So once it is nitinol, we have that property we talked about before, right? You do this to the wire, it comes back straight again. So this is very important as we go inside, because it makes it very possible for us to go inside tortuous anatomy of the brain, but the wire will not take the shape. Have you got it? But we also told you the problem of this is nitinol has got a shape memory alloy. So once you got a shape memory alloy, the problem is you cannot give a tip shape. So what Microvention or Termo did is a very interesting fusion where they bring this nitinol wire inside, and towards the last 2 centimeters, they change the alloy combination a little bit, and they make the tip get flat like a ribbon. I hope you're understanding what I'm saying. Now that combination plus this platinum nickel alloy over here allows us to shape. Now see, like I said, because it's nitinol, it's not very easy to shape it. So if you're going to use this device, you'll find it very, very difficult to shape. I tried to shape it, you see nothing much happens. It's a struggle to shape it. And because of that, the packing that comes with the Traxxas wire will have this component here, which is the shaping tool. I want you to understand, you cannot use any other shaping tool to shape the Traxxas wire. Now I've got this component, I want to show you how we shape it. Now compared to any other wire, you will have to use a lot more force to shape this. Remember, if you're used to shaping the Traxxas wire and you use the same kind of force in other wires, you'll destroy the wire. So here is this mandrel. You take it in your hand, and I want you to see how it is done. So you hold it in your finger like this and you pull it. So you make a curve and you pull it and you get a shape. Have you got that? So you get that point. You hold this between your thumb and the wire, decide the curve you want to give, and you pull it and you get a curve. Now what is interesting is, this is a nitinol wire and we got an absolutely J curve on this, which is technically not possible. But the good thing is this wire doesn't easily straighten. See, I do this, we go inside the vessel, but it doesn't straighten. So one of the advantages of the Traxxas wire is it has got a shapeable tip, which can be shaped with a micro shaping tool, but it will retain the shape. Understand? It is an extremely important property when you work, because you're going inside the brain, the shape disappears, you come back again. One of the greatest advantage of this combination is that, for example, you're going for a patient with a stroke. You have got a clot inside. You take this J shape, and as you push this wire, this goes and sometimes forms a loop like this. You understand? If you use a wire which has not got a nitinol core, the wire will permanently get shaped like this. And after that, when you pull it out, you can never get in. So one of the best wires to use inside the brain for all conditions is a nitinol core wire like this. Remember? But the problem of nitinol is, by itself, nitinol may not be as torqueable as stainless steel. Also, Nitinol is a softer material. So what did this company Traxxas do? They did a very interesting thing. They call it a hybrid or a fused wire because onto this Nitinol core, what they have done is, as we come into the distal component, it is much more stiff. It is stainless steel. Understand? Now, why have they given stainless steel? Because stainless steel as a property is very toggable. It has very little of other properties. So now see, how do we know it's stainless steel? If I bend this wire here, technically the wire will get destroyed. Can you see that? Are you getting what I'm trying to say? This is totally different from the distal end of the wire. I showed you distally that nothing happens. So remember, three components of wire, three different properties. The 140 centimeters of the wire is stainless steel. Remember, you go and buckle it right here, you're going to destroy the wire. And you get it? I bend it, it gets destroyed. I come beyond 140 centimeters of the wire. Now I come to the Nitinol component. As I come here, I do anything to the wire, it bounces back again. Are you getting what I'm saying? Have a look. See, as I come here, this wire is Nitinol, it straightens up. So this became a phenomenal new technology that first came into the world through this company. Can you see this property? I'm doing anything and the wire doesn't get destroyed. Back to normal. Try the same thing in the back here and the wire is destroyed. Are you getting this? I want you to understand this concept of what exactly is the concept of a hybrid construction. So starting once again, the distal 140 centimeters is stainless steel with a polyurethane coating which allows it to be slippery and gives us very good support. So I can push the wire, allows me to torque very well, and because of that, it is fantastic. Distal to that is a combination of a Nitinol core that is running up. It has got, and this component of 36 centimeters is stainless steel, and the last 4 centimeters I said is a combination of of platinum along with nickel. Got it? And so this is a wire which has got multiple properties depending on which segment you're looking. Now I also told you that wire should have a 1:1 torque. Whenever you take a wire, a simple thing to do is to try togging it. Not togging it when it's straight, that is very easy. Everything will tog when it's straight. So I'm going to make it into multiple loops here. You can see this. Loop over here, and a loop over here, and a loop over here. And then we're going to connect a togging device. For all these small devices, you're going to connect a micro togger, or we can't tog it. So here we've got a togging device connected. And see, I want to look at the tip. Sorry. The wire keeps togging. Can you see as I tog it? Although this is in such a kind of a messed up state of multiple curves, you know. So this is called 1:1 togging. When I tog it, can you see how it moves? I hope you can see the tip moving. So this tip is moving, and this is called a 1:1 tog. So that happens because of the stainless steel mandrel. The shape is retained because of a complex fusion they have done with Nitinol, and it does not kink because the core is Nitinol. The tip is radio opaque because you got platinum out there, and at the same time, it keeps the distal end soft and supple by putting just a stainless steel coil distally. So obviously it's an expensive wire because it is a seamless fusion between stainless steel and Nitinol. Remember, it's difficult to fuse these materials because the melting points of all of them are different, but the companies have learned how to do it. Now, in the distal 60 centimeters, we got a lubricious coating, but today all the micro catheters also come with a polyethylene or a PTFE coating inside. So this combination is what makes the micro very trackable. And also it is this combination that makes it very difficult to reuse. Whenever you take a micro catheter, do a ethylene oxide sterilization, the inner PTFE coating gets destroyed. And because of that, you'll find there's a lot of resistance when you take this. Now, Traxxas has got another advantage. I want you to see the distal end of this Traxxas wire. Can you see it? It looks a little funny and wavy. And this has been created because this wire comes at a length of 200 centimeters. Now, suppose you're doing a neuro procedure and you want to do an exchange maneuver. For example, classically, I'm finding it very, very difficult to take a balloon catheter, but I'm able to take a micro catheter into that branch. Now I want to exchange it. So the good thing about this, you can put an extension, which is called a docking wire. So have a look at it. So this is a docking wire, and it is recommended that you keep a togger here. It gives you a lot more support. And I'm going to show you the docking component. So this is a docking component. If you see this here, I hope you can make out. This has got a band-like appearance here and another band like here, and it has got a small hollow component that is present. So you got to actually connect this wire. Not very easy, and you need very good eyes, but technically okay. So can you see it is getting inside this? Can you see that? And ideally, like I said, have two toggers on two sides. It will help you a lot, and you can push this inside. And see, this is pushed, and they will come and meet each other. I hope you can see what I'm showing. Can you see now? It is still not met. There's a little bit of a silver component, but a point will come when you, and that's why I said keep toggers on two sides. Okay. Now can you see it has become fused? It's become like one wire. Can you get this point? Now, once you have done this, remember, you can use it like a wire which has got another extra length, which is like 100 centimeters. You get this? Now see the length of the, we have converted a regular wire into an exchange length wire over here. And so now it becomes pretty simple. You can go, come out and do the procedure. So understand, this is called docking, and Traxxas again makes an excellent docking system. So it is one of the wires we use a lot because of these properties. And remember, the Traxxas is a wire that technically can be taken into an aneurysm because it has got a soft tip. It is softer than a coil. You can see it over here. And once you give it a tip like this, so remember, it's a good wire for stroke. The J component will go in. It's a good wire to enter anywhere because it torques very well. Very good wire for acute or steep angles because the shape is retained. Now, very often people ask me, what shape do I put for a wire? So I told you a simple shape, a J shape for a total occlusion like a stroke. If you're going to the MCA, you don't have to put a very tight angle. I'll show you the kind of angle you need. So something like this is fine for the middle cerebral artery because in general, the ICA goes into the middle cerebral artery. Having said that, you look at the angio and decide. So very often a difficult vessel to enter, it is the ACA, the A1 segment. So I'll tell you the commonest shape I use, but this also can be varied based upon the takeoff of the A1 segment from the ICA. So I often give it a shape which is like a double curve renal. So we got one angle here. Along with that, I'll put an angle just a little below and make it look like this. Have you got it? So there are basically two angles here. So what happens is if you're entering the ACA, it will automatically fall. So remember, it looks very much like a cobra or very much like a double curve renal. Have you got this idea? So see, a tight angle here and this. And if you come to a point where you want to enter the A1, A2, and it's got a very, very tight curve, remember the distal curve has to become almost like a J. So remember this, you go and make it like a J. So sometimes you may have to see that curve. Now this is the kind of curve you'll require often if you want to enter into a very angulated A1, A2 junction. You get this? So this will vary. So sometimes when you find an angle doesn't go, you pull out the micro and change the angle. but these are the different common shapes we put. A simple straight angle, an angle which is like a double curve renal, or sometimes you want to get into a very, very tight angle. You actually make it almost like a tight J loop, and you go in and you're going to micro. It can be difficult, but you tog your way through. Now, like I said, Traxxas makes two type of wires: the EX, which is the extra support, and also the standard wire. How can you know what are the difference? The technical difference is only in the distal part, based on how they construct the distal part, how much length of coil is there, and a little change in the nitinol component. So I'll just try to show you that now to try to make you understand how you can differentiate the two. The simplest way to differentiate the two is taking a length of both the wires. Like I said, both these wires are Traxxas. One of them is EX and one is not. Let me just straighten this to show you again. So like I said, you can reshape a Traxxas wire also easily. Okay. Now see, I'm holding these two wires exactly at the same point, and then we leave it. Okay. Now at the same point, you see one wire is bending more than the other wire, right? Can you see that? So this wire is the regular Traxxas. This is the EX, extra support. Very easy. You can understand this logic very simply to tell you this gives you more support. Can you see as I go further off, you see the bending. It's easy to understand that this is straight, gives you more support. So remember, what does it mean when I give more support? What it basically means is that this straightens vessels. So remember, when you got to cross the Sylvian point and go beyond it, do not use an EX wire, because you're going to stretch the Sylvian point. You may end up in injuring a vessel. So up to the A1, A2 junction or to the proximal A2, it's fine. But when you go beyond it, or the proximal, up to the distal M1, it's fine. If you're going to go 2 to 3 centimeter distal in the M2, you should go for a softer wire. So this is a regular Traxxas, and this is the EX. Also remember, the Traxxas, though is supposed to be a 1,4 wire, the distal component of this wire is 1,2. So what does it mean? Even a catheter like Marathon can take the Traxxas wire because distally it's 1,2. But if you're going to use a Marathon on this for entering into, suppose, the middle meningeal artery, or even into an AVM, you will always use a soft, you will never use the extra support. Keeping this in mind, I want to show you another wire, and this is a coronary wire, right? This is a common coronary wire called the Whisper. Can you understand? Now, why is it that I want to show you this wire? I want to show you just to understand why you should not be using these wire inside the brain. If you understand this basic concept, you will now have a look at this wire. Same length, I'm holding it. Okay, sorry, we're just gonna split these wires up one more. Okay, we got 3 wires in the same length. Can you see this difference? Now, can you understand what this wire will do in the brain? So many people get very excited thinking more the support, better for any part of the body. It doesn't work. You take this wire beyond the cavernous sinus and enter into the A1 or M2, it will be trying hard to straighten your vessel. So in other ways, it cannot straighten this because it's tethered to the dura. The wire cannot be pushed forward, nothing moves. So remember one thing, if you want to do a stenting inside the brain, you're going to use an EX wire, which is of the neuro, which are like this. I hope you get this concept. It's a fundamental concept. A cardiologist may try to do this because he doesn't understand the concept, but all of us who are doing interventions and neuro intervention has to understand neuro wires are much, much softer wires. Whereas on the other hand, this is a very stiff wire. It's very good for carotid stenting, very good for extracranial anatomy, but not meant for intracranial anatomy. With this, you can rupture a vessel, especially if you try to push it to the M2 segment, because these are really rigid. These are very good to take stents across inside the coronary arteries, very good for below knee vessels, very good for straight anatomy, pretty good even to the level of the petrous and even to the point you come to the cavernous. Once you cross the cavernous, it will not work. I hope you got this. It's a 1,4 wire. It is an extra support wire, but not meant for the brain, right? So from here, I will move into another wire technology, which is very, very different from any of these. And that is the technology which is used by a company called Stryker. Originally, it was, as you know, Boston Scientific. And they had a technology from a company called Target, and that is called a Synchro Wire. Now, Synchro is again an excellent wire. But Synchro's technology is amazing. Again, a very, very interesting technology, and I'm going to show that to you to make you understand how it works. Now, this is a Synchro wire. Can I have a look at this? Now, Synchro's technology is an interesting technology where they wanted to make it the most toggable wire in the world. Now, I told you the most toggable material in the world is stainless steel. So they did a thing, but they realized the problem of stainless steel has a problem, the tip will just get deformed. Now the Synchro wire, if you say the tip doesn't get deformed. Have a look at this. You do anything to the tip, it comes back again. Now how do they manage to do that? So they came in much before any of the other wires, and it torques extremely well. Have a look, it's a 1:1 torque, just torques so well. So they decided to make a central mandrel that is made of stainless steel. I hope you can understand. The central mandrel end to end is stainless steel. On the surface of the mandrel, they put a Nitinol tubing. So they reversed it completely. That's why I said it's a total different construction. Different because all the other wire companies were experimenting with using Nitinol as a mandrel. And the company Target at that time, which like today it's sold by Stryker, decided to make an outer coating or an outer tube made out of Nitinol, which was put in multiple slots. So if you magnify and look at it, it's like spiral slots that have been made across a tube of Nitinol, making it very, very flexible. So it's very flexible. Okay, very flexible wire. Nothing happens to the wire because of this property. See, all the way, see, it is maintaining. But as we go distal, it will start bending a little more, but because the steel component becomes more. So how do they keep the distal end absolutely kink resistant? There is no wire in the distal end. So what they did is the distal end is just the hollow Nitinol tube. But what is the biggest disadvantage of this? The biggest disadvantage of this is very difficult to shape it. If you see, you can give a shape, but very soon when you go in the body, it will tend to become straight again. So it doesn't have a shape retention which is as good as the Traxxas wire. But in terms of toggability, it's very good. The tip is very soft because there's no mandrel inside. And again, a very, very good wire for very tortuous anatomy, and especially when you want to torque and enter. Also, they have a coating on the surface, exactly similar to the Traxxas wire coating, but believe me, nobody can match the quality of the coating of Terumo. So if you use a Terumo wire, the coating is flawless. And they say that they have tried to manufacture Terumo wires or glide wires in any place outside Japan, and they're not able to do it. And finally, they conclude it's something to do with the water that comes from the Fuji mountain. Their factory is just at the mountain foothills. Believe me, there is something to it. And even today, even with however good the quality of the Synchro wire is, it can still tend to get stuck inside a microcatheter, which never happens with the Terumo wire. Terumo used to make actually a wire called a gold tip wire for neuro at one time. It had no support, but very toggable. But today with their Traxxas wire, they've overcome that. So if you want to just keep two wires in your lab, these two wires are more than enough. The Traxxas wire, which will get you through most of the situation, a Synchro wire, which can help you cross difficult anatomy, But remember, at times you'll have to pull back the wire, reshape it, because as it goes in the body, somehow it straightens up. And I don't know why that happens, but you can see as I touch it, also it's shaped. You don't need a mandrel. Just as it moves inside the body, the wire shape keeps changing. Can you see how much it changed just with my finger? So ideally, they will suggest that you use this as a shaping tool. Okay, so this mantle is what we use as a shaping tool, because uh, it can be shaped with this also. You can see it gets shaped. But if you want to give a very tight curve, I'll still recommend you use the same tool that you use with the Terimo wire, with the Traxxas wire. Also remember, when you're using this wire, please don't try to insert the wire from this end. It will destroy the curve. Always come from the back and slide it forward and then enter inside and push it inside. Okay, I hope you got. So these are the basic 2 wires and 1/4 which I want to show to you. One is, like I said, the Traxxas EX, the Traxxas Standard, and the Synchro Wire. Now there are many other companies who come with wires. There's a hybrid wire you can get even in the from Balt. It is somewhere close to the Traxxas wire. Not really in terms of property with the Synchro. I find the Synchro very, very, very good if you want to go distilling, where by togging it, it tends to flip and go inside. And it's a very popular wire in a lab. Like I said, the bulk of work is between these 2 wires. You can have a hybrid wire, but it also probably works. And there are some other wires called the accelerator wires and all, but I don't tend to use it, keeping the inventory down. But when we come into another segment, which is a 0.8 wire, look at this wire. You can hardly see it, right? Now, why do you need this wire? Do you have a microcatheter for this? I want to just show you why it's necessary for any of the magic catheters or a microcatheter that you require for neuro intervention, for injecting glue. It will be written clearly that the lumen is 0.08. So when you have a 0.08 lumen, you cannot use it. So what are the classical wires places where you use this wire? So this is a hybrid wire. Now nobody makes a better 0.08 wire. I want you to look at this. This is called the Sonic. And you see over here, they will always write the wire diameter. Can you see it? They write a lot of things over here. This is Sonic. It's a detachable catheter. And they call it a hybrid 007 wire. Can you see it in big letters? Now this is the hybrid 007 wire. So now you know what hybrid means. So every company, including Balt, realized the best fusion is a stainless steel mandrel with a Nitinol mandrel distally. So this is again the same technology like a Traxxas wire, but I think that Balt has got this very, very well when it comes. So have a look at it. Again, same technology where you can give you try to loop it. It won't get looped. It comes back to straight. But remember, this is a very gentle, small, very, very thin mandrel. So you got to use this device to give the curve. So here it is trying to show you what exactly happens. So, and you have to be very gentle. Don't pull the tip out. Just come to the tip and stop. And you get this J. So you understand, we're using this one. You try to use this one. I'll tell you what happens. Use this thin one that you come with the Traxxas. It looked like a pig's tail. Can you understand what happens? It becomes a pretty useless wire and you cannot correct these wires. So remember, it has to see, however hard I try, it's very difficult to correct it. It keeps getting worse. So you're going to use this. Do not pull it out from the tip. Just bring it and stop it short. You know, I don't know if you can see it, but stop it just short, 1 millimeter short the tip. And like I said, it's destroyed. So remember, this is a very fragile wire. It's a very expensive wire. You get one chance. So don't try to over curve it in the beginning, right? Don't put a curve too much. Go slowly. A gentle curve to start with this mandrel. Don't pull it out from the tip and you'll get the shape that you want. And often here you may have to put some pretty acute shapes, but excellent wire. This is called the hybrid wire, right? And this is from, there are other companies that today make it. But I personally feel still hybrid from Balt is one of the best wires that you can use. But there are some, there is another company that exclusively makes wires. Uh, Pardon? Asai. So Asai basically makes also these point zero 0.08 wires, or 0.07, I'm sorry, not 0.08 wires. They also make 1.4 wires. They are reasonably good wires, especially the black. They call it Chikai black. They are good wires, but I think the best thing for you is to get used to just a few wires, 3 or 4 wires, so you know the property very well and you get used to it. So like I said, our first choice for wires in the 0.07 is the Balt wire. And like I said, it's a hybrid wire. It has got a property of nitinol in the distal about 25 centimeters. And after that, you can see it gets stiffer. And then after that, it becomes a steel mandrel. And that's why we call it an hybrid. Very similar to the other. They have put these bands in between to tell you the stiffness changes that take place or the properties. This is actually the welding point, you can see, where they're taking the nitinol component, welding to steel, and you see out here, the wire will get totally destroyed. And you know that that's the end of the wire, and that is because it's steel. When you come over here, this component, the wire doesn't get destroyed so fast. You can see, and it's very easy. You understand this fusion component which I talked. Now you don't need too much of brains. You understand this is all hybrid. Hybrid is a combination, and Traxxas or the first person, the same thing when I do over here, it opens up. When I go beyond the, okay, actually remember one thing, see this wire is broken. That is because of the welding technology, which is not so perfected as that we saw in the Traxxas. Traxxas, this will never happen. So this is the place where they have the nitinol component. So they give a band to tell you don't bend over there. This is that point which I showed you. Now this is steel. And you see if you do this, it'll lose its shape. Have you got it? So they have welded it. It's a hybrid wire. Like I said, I don't know. Termo has got definitely a better technology. It won't break at the junction. This will break at the junction. So it's very important that as you use this, you don't bend it at that point. Okay. So you realize how floppy that wire was? I think you got it. It is like so floppy that will fall down like this. And that is the only kind of wire that you can use for going distally. Have you understood this? See that as you move your hand off, so it doesn't produce any resistance at all. You touch it, it's almost like hair. And these are the only wires that the distal vasculature of the brain can accommodate. If you straighten vessels, remember as the vessel is going in distally, it is giving multiple perforating branches into the brain parenchyma. And you go and straighten it, it will pull these branches off from the brain parenchyma. And you may think you did a great procedure, and the end there is an intracerebral hematoma and bleed because the perforators have got pulled out. I hope you're understand why it's important to use the right wire in the right place. Okay. Before we close, I'll just do one more microcatheter wire, and that is the wire that comes with the pro-grade microcatheter. It is a 0.21 wire. It's much thicker. It comes along with the pro-grade microcatheter. And see this wire. This is again a through and through nitinol wire. See, have a look at it. This is a through and through nitinol wire. Again, understand it's a property of Terumo. They make the best coating. There is nobody in the world who can copy them. And like I said, they tell it's a water from Fuji. I do not know what the reason is. Now, this one is a wire which is extremely good, but can only be used a pro-grade catheter because it's got a hub that locks. And it's difficult to get 2-1 wires by itself, so we tend not to use it, but it's a great microcatheter for the peripheries. Today you got direction, but direction doesn't come with a wire, so you have a problem that you have to use some other wire. So I think the popularity of the Termos Pro Grade is more because they give the wire along with it, because it's got a great wire. See the togging capacity. I'm togging from this end, and the wire will start togging on the other side. Can you see that? It goes through all these loops and it starts togging. So just see that. Can you get this togging that is taking place? Can you see it? That just shows. And also, like I said, you know it's not a hybrid wire because even at the distal end, when I bend it, it opens up again. See? Can you understand? Even if a company guy comes and tells you amazing things, today you can test the wire and tell, see, I'm winding this wire right from the distal part all the way to the top on my finger. We come back and it opens up like this. Can you see that? What does it mean? It's not a hybrid wire. It's a wire that is basically Nitinol end to end. Now, what does this mean? It is not a very extra support wire. You can never make an extra support Nitinol wire. Remember that. The greatest advantage of Nitinol is it's got a reasonably decent torque. Its greatest advantage, it doesn't kink. The problem is it's not radio opaque. And the next problem is it's that it cannot give support. So Termo has got some wires for the periphery, which is a hybrid wire, which is a fusion of an extra stiff mandrel in the distal 2/3, and the proximal 2/3 is a Nitinol wire. It's a very good wire, 3-5 wire that you can use in the peripheries, where you can use the same wire to do a subintimal dissection, cross it, use the same wire as an extra support wire and take your catheter across and complete the procedure in one. Because like I said, Termo knows to fuse stainless steel and Nitinol flawlessly and perfectly, right? So that's a little bit about the classical microcatheter wires that we use today in neuro practice. So like I said, we started off by telling you the property of the Traxxas wire, how the Traxxas wire is basically an hybrid wire. It is a hybrid wire because it fuses two types of wires together, the distal Nitinol with a proximal stainless steel. And we also told that they have much better technology of fusion than any other company, so there is absolutely no transition. We told you the Traxxas has an advantage that the distal 4 centimeters is platinum along with nickel and is shapeable and has got phenomenal shape retention. We told there are two types of Traxxas wires, the EX and the ordinary. The EX has got little more support, so try not to use it into the distal vasculature because it is not as flexible as the regular wire. Both these wires are very, very popular for aneurysm coiling. We're using with 1/4 microcatheters. Can also be used with a catheter that takes a 1/2 wire like the Marathon. Like I said, we have used it very often in that combination also. I talked to you about the Synchro Wire, phenomenal technology, stainless steel mandrel with a Nitinol covering or a Nitinol uh, uh, super tube, which is slotted to give phenomenal torque and again completely prevents kinking to take place. And we also said it is very good when you want to access very, very acute angles and go a little distally when you're working with the cerebral vasculature. At that point, I also showed you a coronary wire to tell you how stiff it is and why you should not be using a coronary wire in intracranial vasculature because they will straighten the vessel and you can end up with a disastrous result. Finally, I told you about the 0.017 wire. Again, today the best wires are the hybrid wires. We talked that Asahi makes some wires, but we tend to use the Balt hybrid a lot because we find it a very, very safe wire. But remember, the problem with the hybrid wire is the junction can break easily because the fusion technology is not very, very well sorted out by Balt so far. But in general, we never have problems unless you do try to bend it at that point. Like I told you, it's difficult to fuse this material. Nitinol is an alloy made of nickel and titanium. Stainless steel is another material. The melting points are different, so fusion becomes very, very difficult. I finally told you in the periphery, the wire that we use in the microcatheter very, very often is the 2-1 microcatheter that comes along with a prograde. This works all the time very well. Remember, the tip of the prograde wire is difficult to shape, and that is a drawback. So when something like that happens, we end up using actually a Traxxas or a Synchro wire and try to cross and then take the prograde, but obviously it won't track very well. So hope you got a basic, reasonable idea. But remember, all these wires are hydrophilic. They have to be kept in saline for some time. Whenever you're introducing them into the microcatheter, the saline first flush must be running through the microcatheter and only then you take the wire. When a hydrophilic wire is not well lubricated, it can become very, very sticky. And your procedure will be intensely difficult and you may have to pull the whole thing off. So remember, It is mandatory. They are all very, very well hydrated, and they are not at all sticky. And with those, you can do it. Like I said, remember, use the right tool to shape and get the right shape based on the region that you're going to go. Look at the anatomy. Like I said, if I'm going to do an MCA, we put a right angle. If you're going to take a total occlusion in a stroke, give a J wire. If you're going to go into the ACA, try to give a cobra-like shape or a double curve renal. And if that doesn't work, change those angles to get what you want. So in the next class, we'll try to go into the 1,4 and the 1,8 wires that we use in the periphery to know whether are all these wires as good as they say, or do we really stick on to again some basic wires. And like I sometimes realize a lot of companies come with a lot of products. Most of them don't have any great advantage. Thank you.